Alright, so our goal here is going to be to continue talking about measuring segments, and in this case we're going to talk about something called midpoint. But before we do that, we want to give you a quick definition, and we're going to introduce a new symbol for you. Okay, so when we have lengths and we measure the lengths of two segments, or not even just segments, if we're talking about two shapes, okay, that are the same, and everything's the same about them, all of the kind of the parts of them, we say that those shapes are congruent. Okay, so this new vocabulary word congruent is showing up. Okay, and so we're going to talk about congruent segments today. Okay, but when we talk about congruent, meaning that they are the same length, we have this new symbol here, which is an equal sign, just with a little squiggly line over the top of it, and this means congruent. Okay, so now we're going to talk about, like, quickly, like what does this even mean, right? What is congruent? So here's the best way to describe this. Okay, when I talk about the length of line segment AB and the length of line segment CD, I'm assigning numbers to these, right? So if I were to say how long is AB, AB is 7 units long. How long is CD? It's also 7 units long. When we're comparing things that are numbers, okay, we use an equal sign. So the equal sign means that the value on the left and the value on the right are the same, so I can put an equal sign in between them. Okay, when I'm talking about line segments, I'm not actually saying that the line segments, that this doesn't mean a number. This is actually referring to the object. So I'm kind of saying the object AB and the object CD have the same length, right? I'm not talking about the actual numbers themselves. It would just be like saying this person and this person are the same height, as opposed to me saying this person is 5'7" and that person is 5'7". So by describing them as just the same height, I'm not using a number. So when we're referring to the objects themselves, we talk about them being congruent. Okay, so this is just referring to, like, oh, here's a line segment and here's another line segment, and if you take a look, they are the same length, right? And when that happens and we're describing the objects themselves, that's when we use this congruent symbol. Okay, so it's kind of just a generic symbol that's used to describe that the properties of these two objects are the same, and so for line segments, the only property we really have is their length. Right, so as we move on and talk about larger shapes like triangles or three-dimensional objects, polygons and things like that, we're going to broaden this definition and say not only are the lines the same length, but maybe all of the angles are the same and the areas are the same and that kind of thing. So just generically, for right now, that's what it means. Okay, so let's use that. And because the word congruent segments is showing up in our definition for midpoint, so now that we know what that means, we can talk about midpoints. Okay, so the midpoint of a segment is the point that divides the segment into two congruent segments, okay, which means two segments that have the same length. So as an example, looking at this picture, if AC is worth 14, and I tell you that B is the midpoint, then you know that the segments that were created by putting B there have to be the same number, which means we can take the entire length, cut it in half, and each of those pieces has to be worth 7. Okay, so that's just a very quick example. So whenever you see the word midpoint, that's going to help you and basically say that the length of the segments have to be equal to each other because the segments are congruent. Okay, so let's look at an example. Okay. Oh, I'm sorry, let me give you one more definition, and then we'll look at an example. So here's the last definition, and it's this word bisect. Okay, and we're putting this in here now because bisect is related to midpoint. Okay, so if I have a line or a ray or a point that intersects a segment at its midpoint, we say that that line or that ray or that segment bisects the segment. And what bisect really means is to cut it into two pieces. Okay, so there's a relationship between bisecting happening and midpoint, and that's why these things are going to kind of be put together. So if you notice what's happening here, I had that same line AC. Okay, the midpoint was at B, and we drew this line that went right through B. So we say that this line R is bisecting AC, okay, at the point B. This is usually the bisector of AC, not AB. Okay, so from A to C, we cut it right in half through B, and we created two equal segments. So the word bisect for us, for our purposes, is going to mean something very similar to the word midpoint, okay, because a bisector goes through a midpoint and kind of does the same thing, creates two equal segments. Okay, so they are related terms. When you see bisect and when you see midpoint, you kind of think the same thing, and that is, okay, I have two equal pieces now. Okay, whatever the big segment was, I can just cut that in half. Okay, here's the last little thing, and then we're going to talk about we're going to do a problem using midpoint. So these dashes, you might have noticed these on my diagram here. If I don't want to have to write out in words that midpoint is happening or that bisect is happening, I can also indicate that on a diagram without actually having to explicitly tell you that B is the midpoint or that R is a bisector. Okay? And the way we do that is with these dashes. If I put 2 dashes on a line segment and I put 2 dashes on a different line segment, what we're indicating when we do that is that every line segment that has 2 dashes are equal in length. Okay, so from A to B, if this was worth 12, every other line segment that also has 2 dashes on it is also worth 12. So if this would be worth 12, and let's say there's another little line segment here and I put 2 dashes on that, this would be worth 12, right? So it's our way of, without numbers, okay, indicating that line segments have the same length, that they are congruent. Okay, so you'll see that show up in a lot of our diagrams. It could be let's just do another kind of quick example and then we'll move on. So if I were to come up here and say, again, here's another set of line segments, we'll put like Q and T, okay? If I were to put 1 dash on this one and 1 dash on this one, I would say from Q to B and from B to T, those line segments are the same length, but they are not the same as A, B, and B, C, which have 2 dashes. So we use a different number of dashes for every different line segment, okay? So here's our first problem, and I think it's the only one we're going to do. Okay, and in this problem they're saying Q is the midpoint of PR, and they want to know what are the lengths of PQ, the length of QR, and the length of PR. Okay, so we're going to do this problem, but I want to point out a couple of things that are kind of similar and different. Okay, if you remember the last problems that we did in the last video about segment addition postulate, here we saw this kind of line segment like this in the last one as well, and what we said was PQ plus QR is equal to PR. Okay, and that's how we when we saw this picture of a bunch of segments, we wrote all that out and we said, great, look, awesome, we have this postulate that says that this is true. Here's the problem. If I were to start filling in the blanks here, I have something that I can put into PQ, right? I have this 6x minus 7. I have something that I can put into QR, that's 5x plus 1. But if you take a look around, over here was where it said PR equals, and we don't know that now. Like, so I'm kind of like, sorry, I can't finish this expression because I don't know what PR equals, right? So we're missing something, and it doesn't let me use the segment addition postulate. So we can only use the segment addition postulate when I know about all of the parts of the line segment and the line segment itself. So because we don't know about the length of the line segment, we can't use the segment addition postulate. But we have a different piece of information, and that's this one right here. They say Q is the midpoint. And that should trigger something else in your brain, and that is that the length of PQ and the length of QR are the same. So I can say PQ, the length of PQ, should be equal to the length of QR. And so if you notice, when the word midpoint shows up, I don't need to know anything about PR to set these equal to each other. Okay, so I can say 6x minus 7 should be equal to 5x plus 1. And this is a pretty quick solve. When I subtract the 5x to the left, I get 1x. When I add this 7 back over here, I get 8. Okay, so again, there's my answer. Great, x equals 8, except it's not the answer. Okay, so we have to be careful again. In this case, we don't want to know what x is. We want to know about PQ, QR, and PR. So when I plug in the 8 times 6 is 48. 48 minus 7 is 41. And then let's make sure this works. If I plug in an 8 here, 5 times 8 is 40. 40 plus 1 is also 41. And so if you notice, Q is actually coming out to be the midpoint because PQ and QR are the same length. We created 2 congruent segments. That would mean that the length of PR, using the segment addition postulate, is 41 plus 41, which is 82. Okay, so now I can answer the questions because I know the midpoint. Again, so again, just be very careful. Midpoint indicates that the 2 segments are equal. Segment addition postulate is only when we know about both of the segments and we know how long, or at least we have an expression for the length of the entire line.